So my name is Munakata. Thank you for introduction. And initially, I promised you to share my slide because I just finished 30 minutes ago. So I never uploaded, but because today I had quite a lot of data, so that can be used. Okay, so hopefully this should work. Okay, so I usually say the make or buy to the collaborate, because this is an important message. Because open source is everywhere, the automotive industry people also start thinking seriously about how to use the open source stuff. So collaborate means a partnership with other companies or communities. This is important. And I was traveling to the Renesas All Member Meeting last month. I give you the slides later. No, don't worry. Okay. So I was shocked. You know, they say make or buy or assemble. I was very, very shocked to hear that. So I hope some of you feel that. But my biggest question was no one raised hand at this conference. Yeah, actually, there are more than 50 people joining this conference. But it implies me that the automotive industry people think open source as a product compared to the commercial product, and which is cheaper, which is easier to use. So the majority of open source industry people, except these people, are thinking the open source like this. So my feeling is that actually the other industry, like IT industry, the infrastructure industry, people already think that without open source, we cannot survive. So that's why they are seriously contributing and collaborating to the community and partnerships. But they are thinking open source is just one option and wait and see attitude. So unfortunately, this is a reality. So that's why today I want to share the fundamentals of open source. Open source is not a product, differing the long-time history of the Linux kernel development. So by the way, the recent Linux is quite stable. It's almost like a product. So this is the latest one. So maybe the old man, like Takasami, have a special feeling about the 7, because there are many 7s, because Oracle 7, Windows 7, many 7 names. But the Linux 7 is not a product name. This is just a version name. So you can see here, this is the latest one. And this is a Windows case. Windows 1.2.3, 3.1 is directly quoted from its version numbers. And after that, they start using the 95, 98 millennium. It's a kind of the year name, basically. And then suddenly they start using Windows 7. But it's actually internal code name NT 6.1. So that means Windows 7 and the Windows Vista is some kind of sisters. It's based on the same code base. And like same, the Windows 10 and the Windows 11 also they're using the same baseline. So this is essentially same one. Now Microsoft decided to use the name of the 25H2. This is a newest scheme of the naming in the Microsoft. But in the Linux case, this is a Linux message. So he says very important thing. So we have new major number purely because I'm easily confused, because they don't want to make a big numbers. So he says we haven't done release based on the features, because that means stable or unstable and long term no. And he says number is just a number. So I can quote something, because this is maybe, I don't need to give you so much about this, but this is a Linux development flow. So once 7.0 released, so immediately after the merge windows open for the next one, for the 71. So this is actually this I took it yesterday. So 7.0.6 is today's latest one. So this is a part of the stable release. After releasing 7.0, so we are already moved to the 7.0.6. This is a stable release, adding the kind of minor upgrade. It's already happening. At the same time, today the 7.1 RC3, release candidate 3. So after the RC1, they close merging a new stuff and consent on the validating. So this is the way the currently Linux is working. And at some point, mostly the 7 or 8 weeks, we take a validation period and make a release. This is a cadence of the modern Linux. And this is the way, so each developer, now we can see that more than 2,000 developers working together separately in the different regions. Working together, and send the code in the maintenance, and send it to the one step further, the subsystem maintenance. And they get reviews. Typically, each developer's request to the rewrite the code maybe 5, 6, 7 times. It's normal. Even very experienced developers, they need to rewrite 3 times at least. So this is a way so they can keep the quality and then pull into the Linux next. Do you see the green one? The Linux next, the pull of the next one. And then finally the Linux pulls it. This is a proven way of the modern Linux. And this is a version 6 is 6.0 to the 6.19 and then move to 7. And 5.0 almost same, the 5.0 to the 5.19. And this yellow colored one is LTS, long-term support stuff. This is extended maintenance period. And almost the same in the 4.0 and also 3.0. The interesting is it's 4.16, it's hit a meltdown spectre issue. It took a bit longer than, because formally this roughly the 63. Oh, one important thing is, do you see some regularity of this one duration? The 63, 70, 77. Do you understand? So every Linux kernel release happens on Sundays. US, the California time Sundays. So that's why 63, 77. So, and this 4.16 took 77, longer than the regular. It's based on the spectral meltdown issues. And similarly, the 3.5 hits a bit longer. Actually, 3.1, this is a long place. 3.1 takes 95 days because at this time the kernel org servers are hacked. So this is happening. So this creates some bit longer than. So please take a look at this number, sigma. In Japan, the Hyojun Hensa is this validated day. So the latest 6 is 2.8, and 5.25, and 4.22, and 7.71. Because that means the release cadence is getting stable in the almost 63 days. This is very, very important thing. Okay. So then, today I want to look into the bit older days. Because AGL already started maybe 15 years already around. So I want to go back to the 15 and 20 years ago. So that's we started. So that was age of the, actually the 6.7, 4.20 to 50. So the blue one is just a number increase, no special meaning. But before that, for example, the 2.4 series and 2.6 and 2.2 series 2.4 is a special meaning, and especially for the 2.2 and the 2.0. This is a huge bit difference. And most importantly, there was a development branch beside the stable branch. So this is normal development branch after the V3 series, but formally we have two stuff. So please take a look into this one. So this is the brief cadence. So as mentioned, after 3.0 series, it's almost stabilized. The release number is around 20, 19 to 20, and they take roughly 63 and 70 days. But before that, the situation is completely different. This is important. For example, if you look at the 2.6 series, the duration is much longer. And most importantly, the sigma is much, much bigger. So sometimes very short, sometimes very long. It's not managed. And actually, the cadence, so 6 series, 5 series, 4 series, roughly release around 2.5 years, 3.5 years release intervals. But before that, interestingly, initially the stable version, the development version, green one, 2.1, 2.3, 2.5, is coexists in the stable one. That means the green, the development version is very, very unstable. And people cannot use that. That's why people request the most stabilized one. Then they have an even number 20, 22, 24. And the 24 is a very special one. It's keep maintained over the right before 3.0 time. Because embedded folks don't like 2.6 series. Because 2.6 is too big at the time. So people want to keep maintaining 2.4 series. So this is why. So let's look into the, for example, this is 2.6 series. So 6 series, maybe you can see the duration, after half is 65 to 80 days. Around the average 81, and the sigma is 9.8. So this is the rest half of the 2.6 series. And before that, early stage of 2.6 is very, very different. Because if you see, for example, the 2.6.4 for this one, so stabilization, almost no stabilization, no RC. Just send the code. And most importantly, the 2.612 timing, they start using a Git. Before that, the kind of human management. So no, because that's why you don't have any actual number here. But the early states are very different. And also 2.4 series, so many things, but you can see that someone is released 5 days, 2 days. These 5 days, 2 days, 4 days stuff is they right after release they find a serious bug and they immediately update the release. That happened in the 2.43 time. In some cases, 2.4.33, it's continued to almost 1 year. So 2.4 to 37 is almost 1 year. So it's not formalized. It's random at that time. So, and interesting is the development branch is more aggressive because you can see most of the release happen almost every week. So this cannot be used as a product development, not like today. So what happened during this period? This is very important. So during this period, so they have many important essential changes happening. So the scheduler change, the batch memory write, complete write, preemptority, the block layer rewrite, the driver model changes, K object, module changes. This kind of essential software component changes are happening during that 2426 period. By the way, so do you imagine why I'm talking this old story? So I think we are exact same situation right now. So as the word pointed, the SDV mandate people to completely relate because the developer numbers great increasing, completely new stuff is integrating. So our current situation is a Linux state in a 2.4 and 2.6. So that's why we should learn how they manage to stabilize the large software development. So let's look into that. So early days, developers are around 500, and the maintenance is also very small. And almost they directly sent to the Linus, but Linus asks, Alan Cox did a great job for that one at this time age, but they cannot manage. Sometimes just integrate or make and find bugs and then release. This was very early days of Linux, not like today. This was a very early day of the 2.4. And after that, the Andrew Morton comes. Andrew Morton is one of the maintainer, subsystem, memory management system. He's initially only responsible for memory management, but Linus asked Andrew to test, pre-validate before sending me the patches. So then this Andrew Morton becomes a big gate for the developers. And Andrew Morton worked as some pre-testing field. So merge every key in the MM tree and test it. And if he's OK, in some cases, he asked the developer to rewrite the code. So this is a managed manual control of the development. This is the early days of 2.4. The rest of the 2.4 and sometime in the 2.6. So this is roughly the MM3 started some mid of the 2.5 and continue right before the 3.0. So point is how they can stop this kind of human-operated maintenance done by the MM3. So there are some key points. One is Git. Git is not just a version control. Git immediately realizes some kind of distributed validation. Each different party can separately test and validate before sending the code. So this is an important aspect. So that's almost like a local MM. So each subsystem can have their own MM3. And the RC process. So as mentioned, now we have limited to merge Windows open, and the remaining rest of the 6-7 weeks, they take time to the validation, only for the validation. Stop merging and take a time to validate. This is the kind of formal this one. And of course, at this time, now we can use CI/CD, automated testing from this timing. And I think most importantly, time-based release, time-based periodic release, like a 63 days, 70 days. Even missing some features, they committed to release. And if someone cannot fit in that timing, so postpone to the next one, because they have already committed to have a next release. So don't rush. They take time. And then so this time-based periodic release is not happening in the automotive industry. So that means that we should have, for example, the yearly update, 6 months regular update. This kind of the time-based release is a kind of important stuff. So this is the latest 7.0 snapshot. So we are, this is our kind of introduction. So we are now in around the 10, 15 range. And some people doing that. And back to the 2.6. Actually, this is a very fast Jonathan Corbett. This is a Greco-Hartman kind of special scripts to make this kind of stuff. And you can see that at that time, we were not Renesas Electronics. We are at Renesas Technology at the time, but almost the same position. And you can see that, for example, at this time, the 6.20, the IBM is the biggest contributor at this time. Do you know the RCU? That is Paul McKinney is working very hard to implement that kind of core essential functions. So that is, maybe Taka-san knows RCU. Yes. So this is a very, but you can see the very, very famous name here. So, but this is, you see that this one looks pretty similar, but if you see difference, so the 2627 was released in 2008, and 7.2000, it's a 70 years difference, and the code size becomes roughly 4 times bigger. And the interesting is the contributors number is not so different, roughly twice. But use modern technology, so after V3 series, the Linux became more stabilized, more formalized. This is a very important changes. So what's happening here is this is a growth rate, you know. So early days, it's changing a lot because the code size is now 4 times bigger, but change different is making very narrow. So that says Linus always says this is not a special thing. Some minor update and some improvement happened, but not big change is in this release. So this is important. So they could manage, so minimize the sarcasm delta. And growth rate is also getting saturated. So we need the automotive industry now facing so how to manage, how to tackle this kind of big shift of the large software stuff. But this kind of management may be needed. So we should learn. So again, so I say the distributed ownership and the stage integration, MM trees, and automated validation, and lastly, the time-based engineering. This is important. So we should learn from here and how we, because currently there are many companies struggling to collect the software engineers and how to merge them, how to test them. But this kind of distributed validation and also time-based release is essential for stabilize the software stuff. So maybe this is a very good reference for the automotive industry. Yeah, maybe that's why I've quoted many data this time. So hopefully you can review this and learn from here. I have never checked my time, but almost 20 minutes. Okay. That's it. So I will update my slide later. Okay, thank you very much. Yeah.